gait analysis and gliding behavior in skiing. Gait analysis is the way how a person walks, and gliding behavior describes how this person is skiing. For instance, alpine skiing or cross-country skiing, as shown in the photo on the slide. My co-authors are Svenja and Jens Hollenbacher. They belong to Molypso, and Molypso is a company in Langenfeld, which is close to Cologne. The presentation is divided into 5 sections. First, I'm going to talk about ski tribology a little bit. Then I go over to gait analysis, followed by skiing analysis, consequences, and then I sum up the presentation. In tribology is always, as you know, a systems approach. So we have to define the friction bodies first. And so we have here a ski base shown in the lower left corner of the slide. The ski base is made of polyethylene, and it receives grooves and ridges by stone grinding, and then you receive a typical structure used for cold or for warm, wet snow or dry snow, whatever. The frictional body, the counterpiece is snow. Here we have an image of compacted snow. This is not new snow, so you do not see any snowflakes. This is compacted snow, and snow is composed of millions of individual snow grains, and these are actually a whole bunch of ice grains shown in this image. And the ice grains, they can either be connected, this is called the sintering state, or they can be loose. For the case of warm or old snow, then we have separated grains in contact with the snow. The substance in between ski base and snow is a fluid, and the fluid can either be air or water. It's very hard to show how much water is in the contact, because the water is placed on each of those snow grains, and the water film thickness ranges between 1 and 100 nanometers. So it is very complicated to image this, but it's in between, and it serves as a lubricant for skiing. There are a couple of influences on friction in skiing. Here you can see the coefficient of friction as function of the snow temperature from 0 degrees down to -17. And the curve looks like a hockey club. So it has a valley as to maxima. And on the left-hand side at low temperatures, we see a plowing effect. And the plowing effect is caused by plowing of harder snow spheres, snow grain through the ski base. This makes resistance, and this causes friction. The warmer the snow gets, the less the hardness decreases as well, and we go through the valley, the minimum, and then the friction curve goes up again, and this is caused by capillary action. This comes from free water between the snow grains, and this has its maximum at 0 degrees Celsius. There are ways to shift the curve up and down. To shift the curve down, the sliding velocity can be increased, should be increased. The normal force can be increased, which is a little bit more complicated than the sliding velocity, and the contact area should be decreased. And the decrease can be introduced by structuring the ski, either by hand or by grinding structures. And all the 3 measures ends in an increase of friction power density. And as a tribologist, one always has to think in terms of energy and energy dissipation, and this energy goes into the increase of temperature of the snow, thereby increasing the water film thickness, and this means we have a better lubrication situation and the curve goes down. The other way is possible as well, when either snow or air humidity or both are high, the curve shifts to higher values. When there is precipitation in form of fog or rain or snow, we increase the curve as well. To go towards the gait analysis, we need a device, and this device is a high-resolution force measuring plate, and this plate has 15,000 integrated sensors. The force plate has a width of half a meter and a length of 2 meters, and here we have a skier on it with alpine skis, and you see an impression of the pressure distribution. You see the tails of the ski around here with 2 peaks. We see the location where the boots are located, and we see a little bit of the tip of the skis, but the image is a little bit too bright. But this is the image of the pressure distribution while standing. So this is the static measurement. When we want to have a dynamic measurement, we have to send the person from A to B and back. And then we have time to analyze the contact situation with the right foot in green, the left foot in red. We have in between there's a swinging state, then we have again the contact. So we can analyze the gait here, and we receive many single images. And when we combine all images in one image, we receive the black one at the right hand side. This is the complete walk from A to B, and we superposed all the images received from the left hand side and created one single image which show all the positions during walking across the platform. What we see are high pressure areas like here or here. We see low pressure areas underneath the heel. We see the center of gravity, and we notice that the center of gravity is perfectly under the foot. Is supported by the right foot, and there's almost a straight line which stands for a nice walking, nice type of walking without any disturbance. On the left hand side we see a problem. There's an S-shaped curve right here in the middle, and this is because this patient, this proband, had an anterior cruciate ligament rupture in the past, and here we still see the impact of this ACL rupture because there's a restraint. It either hurts to walk, to use the left leg, or the ligament does not allow a nice movement pattern like on the right hand side. So we see this from walking across the platform. The gait analysis looks like this. We send our athlete from A to B. Here we have covered, for the skiing experiments, the force plate is underneath, covered by a low friction carpet. So first we go for a walking analysis, what is actually the gait analysis. And we see one problem, one medical issue right here. And in medical terms, it's called Hallux valgus. And in normal terms, we see that it is red, it is swollen, and it hurts. So this Hallux valgus, it can be repaired somehow, but is a complicated issue. And so this athlete has this issue, and we'll follow this during our next slide, how this influences the gait behavior and later on the skiing behavior. The first impression we got is from a standing analysis. We see that the athlete tries to stand on his right foot and leans a little bit forward. We can see here a peak caused by his toe. We see a little bit higher mountains on the right hand side. And in terms of numbers, we see here 114% to 112, 72 to 67. So this is the first idea we received, that he tries to avoid standing on his left foot. And so with the next slides, we followed up this situation and did some more highly resolved measurements with the force plate. This is a so-called butterfly diagram. You can recognize in gray the feet, left one and right one. This is an analysis while walking, and we see the butterfly depicts this, the path of the center of gravity. So we start, the initial contact is at point 1 here. His heel makes contact with the force plate. Then the foot rolls until it reaches position 2. Then there's a lift off. From 2 to 3, that's the swinging state. And here's the second contact now with the left foot, rolling sequence and lift off at point 4. Again, we noticed the shift to the left-hand side. The athlete tries to avoid walking on the left-hand side. We see it that the time he spends on the left-hand side is lower than the time he spends on the right-hand side. And he tries to walk on the outside of his foot to give his problem location a little bit of a rest. And that's why we see more intensity here, and we see more scattering of the center of gravity path on the left-hand side. So this caused by pain of his hallux valgus. And caused by the same issue, we see a risk of joint stiffening both on the left-hand side and on the right-hand side. And this has to be treated, and I'll show a little bit later how this can be treated. In terms of numbers, we see that what we saw before, numbers, newtons standing barefoot, 351 versus 409. So the left shift can be seen here. When we add those two numbers, we end up at 700 and around 60 newtons divided by 10. So this is weight, it was 76 kilograms. So this fits quite nicely. And when he walks, there's some acceleration involved, and we evaluated a complete walk across the plate. So that's why we have bigger numbers here, but we see again the difference in the numbers. Now let's switch to skiing analysis. The athlete comes from the right-hand side. He slides across this low friction magic carpet. He slides across the force plate and he leaves to the left-hand side. And the athlete was asked to perform one double poling while on top of the force plate, which is shown here. His poles, then he slides across, and we monitor the entire path across the force plate. This is the dynamic force distribution. Again, the movement from right to the left-hand side. We see his left ski, his right ski. We see the differences. We have lower forces here at the tip of the left ski. We see low forces under his foot or his binding on the left ski. And he has higher values on the right-hand side. So the same happens. We started at Gait analysis, static, dynamic, and then we see that the whole thing comes back when the person is skiing. The numbers, the force distribution while standing, again 349 to a 367, the big difference. When we measure the entire double poling cycle, we end up here. And although averaging across the entire cycle, we see those differences, 12,000 to 14,000. So this is again a proof that the deviation in the gait behavior and the gait pattern, this goes all the way to the skiing position and to the results for skiing. For tribology, it's very important is the contact area. And we know that, especially for skiing, the less contact we have, the faster we go skiing, the faster we slide. And we see here the contact area of the skis in standing position. And again, we have, he tries to avoid standing on his left ski. And we see this by receiving a lower contact area. Now let's do a little bit more tribology. What are the consequences of this left-sided decompression? Decompression means that there's a less normal force on his left ski, as shown for walking, the same here. less force for the case of snow and ice results in a higher coefficient of friction. And so when he double poles, he feels a torsion of his upper body because his right ski moves better than the left one. And in summary, reduced normal forces result in higher friction. Higher friction causes torsion while double poling. This is, of course, leads to a loss in propulsion. The guy gets slower. And after a couple of kilometers or days or weeks, he feels lower back pain. And when fatigue moves on, he may also go into an ACL rupture, which moves him out of competition for at least half a year. So this is a very complicated tribological biomechanical issue. What can we do against this? We can help to find the right selection of ski in terms of stiffness, flex, and torsion. We can send the guy, the pro band, the athlete to a boot fitter. It must be a professional one. Maybe the boot fitter brings some more space for his left foot into the boot that he has as a pain reliever. Since he has a different situation for the left and the right leg, there is a different muscle situation. There might be an adaptation of the training sequence. And when biathlon involved, he is a biathlete. When biathlon is involved, we also have to combine the gait analysis, the skiing analysis, and the standing analysis to go for a good position for shooting. My last slide is devoted to the summary. So we see with our gait and skiing analysis and tribology analysis that there is a complex gait pattern that influences biomechanics and tribology. Tribology fires back and influences biomechanics. So this goes back and forth, and this has to be solved. The gait analysis helps to analyze medical issues, for instance, the impact of the cruciate ligament rupture or anatomical specialties like his Hallux valgus. And the gait analysis supports the selection of ski equipment. The gait analysis helps as to send the person to a boot fitter and equip the boot fitter with the right set of initial information that the boot fitting will be successful. Okay, this is the summary of my talk, and if you're interested, I would like to redirect you to my webpage, to my journal called Gliding. This is an open access journal, snowstorm-gliding.de, and there you can find many papers dealing with tribology, biomechanics, skiing, and bobsleighing. So be curious and have a look, and thank you for your attendance of the talks. Thank you very much.